Hello, my peeps. This Algebra Nation video will cover Algebra Nation Workbook, page 16. Giddy up.
Hey there, remember what unions and intersections are? Good. Let's try a practice problem. So, the set V represents all the set of the numbers Vanessa has worn on her uniform playing softball. The set C represents all the numbers that Chris has ever worn on his uniform playing basketball. Vanessa and Chris decide to do an art project where they'll write down all the numbers that they have worn, all the numbers that they have both worn, and then they'll color it green. So first thing we want to do is we want to find the union between Vanessa and Chris. So we'll do that first. So that way Vanessa and Chris can know which numbers to include in their art project. And then we'll find the intersection between Vanessa and Chris's sets so they can determine which numbers to color green. Okay, so remember when you're finding a union, it's almost like adding. So we're going to take all of the elements in Vanessa's set, and we're going to add it to all of the elements in Chris's set. The only difference is we eliminate any duplicate numbers. For instance, you see we have a 3 in Vanessa's set, and we have a 3 in Chris's set. So instead of writing 3 down twice, we'll just write it down once. Okay, so let's try our hand at it. Okay, so B union C. So it's going to be equal to, and remember when you're writing the Vanessa union Chris, you always want to write it in numerical order, smallest to largest. So the first number is 3. Well, we have both of them. It's fine. Then will be 5. Then 6. Then you see 8 is next. And then 9. And then we have 10. Then 11. Actually, 11 is in both of them, which is fine. Then we have 17. Then next we have 18. And then finally we close our set off with 25. And that right there would be the union. This up. So that would be the union between Vanessa and Chris. So now what we want to do is we want to find the intersection between Vanessa and Chris. So what I'm going to do is I'm going to take my green marker and I'm going to go up to the 2 sets at the very beginning of the problem, and I'm going to underline any numbers that are duplicated in both sets. Make sense? So 3 are in both of them. 6, 5, no, neither one. 8 and 9, no. 10, no. 11, yes. 17, no. 18, no. But you can see the last one, 25, is. So everything we underline would be what would make up our set of Vanessa's intersection with Chris. So now down here, B intersection C. And let's go back up to the top and see what those numbers were again. So we had 3, 11, and 25. So 3, 11, and 25. So when doing the art project, Vanessa and Chris will write down all of the numbers we see up here in blue. That represents the union between Vanessa and Chris's uniform numbers. But they will only paint the numbers below that we see in green. They'll only paint those numbers green because those are the only numbers that they both wore. They both had in common. So that was 3, 11, and 25. Hope that was helpful.
Brain break. Maybe we should do this before the state exam in May.
And as the smoke continues to hang around Eden Park, the All Blacks prepare to do the haka.
Maybe if the Bears and the Gators had done that before the games this past weekend, they would have won. Problem number 2.
You ready to try your hand at some more intersections? Okay, this practice problem. Numbers on a bike clock can only contain numbers from the set N. The set S represents the numbers in Sean's bike clock, and the set A represents the numbers in Amy's bike clock. So the question they want us to examine is, what is the sum of the numbers in S intersection tilde A? Two things. Remember what sum means. It means to add the numbers up. So if we were to sum up the set A, it would be 0 plus 3 plus 4 plus 7. 0 plus 3 is 3, plus 4 is 7. 7 plus 7 is 14. So the sum of set A would be 14. Okay. So they want us to find the sum of the set S intersection tilde A. So we know what sum is. We just talked about it. And tilde A. Do you remember what that means? That means everything not in A. We want to find, basically what we want to do is we want to see what in S isn't in A. Okay, let me reword that. We want to find what elements of S, what elements does S not share with A? Does that make more sense? Yeah. What element does set S not share with set A? Let's go up here to set A and set S. Okay. Set S and set A. Okay. And let's eliminate any value, any element in set S, which is also in set A. It's 2 in both of them? No. So we leave that. 4. 4 is in set S. It's also in set A, so let's eliminate that. 5? No, it's not in set A. 8? No, not in set A. So then, S intersection tilde A